Hi, I'm Zara and I'm a first year PhD student over at Monash University, and I'm looking at the impact of binary evolution on the nucleosynthesis and stellar yields of low to intermediate mass stars. So low and intermediate mass stars dominate the evolved stellar population, and they are thought to contribute to roughly half of the galaxy's carbon. Stellar yields are a key ingredient of galactic chemical evolution models, however they often estimate their yields from only single star models, which is an issue since stars are observed to commonly have companions. So is it accurate to assume yields from only single-star models? To answer this question, we have used binary population synthesis code binary-C to evolve 45,000 synthetic stellar models at solar metallicity. And we have found that key binary mechanisms such as mass transfer and mergers can have a dramatic impact on the stellar yields of individual systems. Looking at an example, we have here the carbon-12 yields from a 3.81 binary primary star of varying initial secondary mass and initial orbital period in comparison to a single 3.81 solar mass star. And the most obvious example of binary influence on the carbon-12 yields is this dark red region where our binary primary star is underproducing by over 2 orders of magnitude compared to our single star. And this is due to stable mass transfer early on in the star's evolution. So binary influence can have a large impact on individual stars, but what happens if we look at a stellar population? So we have here the carbon-12 yield of a stellar population where half of the systems are binary in comparison to an only single star population. And we can see from our low to intermediate mass range that we see a total difference of less than 2%. So this suggests that binary stars have little influence on the total carbon-12 yield of the population. A caveat to these models is that we are not including stellar yield contribution from novae and supernovae, so that would be interesting to see how these results change with their inclusion. However, that's all from me. Thank you all for listening.